here. This is an overview of SimDec applications that we did in the book. So if you're lazy to read the entire book, you can just go through this chapter to get a glimpse of what we have done there. Yes, so we have what, 10 different cases, 10 collaborations with very different teams from different science domains. And there was quite a few from business with investment valuation, public support of infrastructure projects, so the policy side of it, 3D manufacturing and construction, some innovative technologies, deep tech market opportunities, which is, that was a cool one because there we actually converted the qualitative modeling concept into a quantitative model and then simulated it and then got very interesting insights. So anything is truly possible with SimDec. Then there was an environmental component, things like a carbon footprint of COVID masks, critical mineral exploration, and evaluation of technical economic assessment of Power-to-X technology. And then there was an engineering part. One was about structural reliability. And another one was on superconducting magnet design. And then one more cool chapter that we put together was on personal decisions. We, mapped it as behavioral science, but practically it's a bunch of questions that we all as individuals deal in our lives and the ways we can convert them into models and analyze them with SimDec to make better informed decisions. Yeah, so from buying the car to moving to another country, or even checking your fitness levels, everything can be looked at from the prism of SimDec. In terms of modeling arrangements, yes, there were very different traditions of modeling. Little people used sensitivity analysis. Some used one at a time. Some used scenarios. Some even went as far as Monte Carlo simulation. A lot of models, surprisingly, a lot of models in Excel. And then some other models, some other softwares in already specific application domains. And those often actually pose a problem because you cannot, first, it's not easy to reformulate the model in a more liberal environment, and it's not possible to simulate it, for example, in the original software, and then it's truly nightmare. Then you either need to again redo the entire model somewhere else, or you do one simulation manually at a time, and like getting 1,000 is just really not very fulfilling work to do. Yes, and so also very different types of modeling in terms of their modeling conventions and questions that they answer. So that was truly diverse experience and very interesting to work with all those teams, and it created a immense amount of experience for us on what kind of model exists, how SimDec can be helpful. And surprisingly, everybody here is left happy with application of SimDec. Many of these people continue to apply it further already without us, some with us still. So it's been great. Great, very interesting, and with a follow-up. Yes, and some SimDec pearls. Well, a few to show heterogeneous effects. Here from the reliability model, it's a beautiful nested, double nested effect. So let's just have a look. I specifically anonymized everything, or pseudo-anonymized the variables, so we are not dealing with the context of the problem. It's too difficult to grasp in a couple of minutes, or impossible for me to explain it, to be honest. So that fast. So what we have? Look, first of all, when A is low, the blue one, then output stretches through its minimum to almost its maximum, so it's all over the place. But if A is medium or high, you can actually kind of constrain it in a very specific ranges of the output. So yellow and green distributions are very, very narrow compared to the blue one. Then if B, this is already gets complicated. Wait a second, I need to move this video a bit. Yes. Good. If B is low, okay. B low or high actually makes little difference in A being high or medium. So in yellow and green, because the distributions are very narrow, there is not much effect going on with the B. But when we look at the blue one, we actually have a lot of influence from B. Low sends you to the lower part of the distribution of the output, and high mostly exist on the right part. And then also C here comes into play, which is if we look into B, particularly in the A being low, then if B is low, then different states of C overlap quite a lot. But if B is high, then you actually have a big chunk of C in the upper range that is not overlapping with other states. So you see, this is terribly complicated, but it's super interesting to know such intricate behavior, such nested behavior about your model. Here the researchers did already excellent work in running iteratively one at a time analysis. So there were like 16 different graphs, and they were able to make some similar conclusions on that. But then only with this single graph we were able to portray this nested pattern properly visually in one graph. So that was one beauty. Another beauty was with the CERN model. I think that was the pattern that they were very uncomfortable with because they didn't know about it and were not able to explain it. Yes, but the work is going on, so there will be progress in that respect. But what we can see here, so the scatter plot on the right down, and by the way, here we can see for B only 3 points. You see, so we did the full factorial design, so only 3 points were evaluated. But anyway, on the scatter plot, we don't really see much influence between B and Y. But on the SimDec histogram, we see a very, very interesting pattern here. So there are 3 different levels of A, right, that are shifted, but then B, which we thought doesn't have any influence, it actually has a lot of influence. Look at the shapes, at the shades in every single color, within every single color. So for example, if we focus on low A, the blue shades, then low and high B are located in the center of the output, and medium B is actually on the sides. So it's kind of a U-shape dependency, but it's nested U-shape existing in different states of A, which makes it hidden when you not using the multi-dimensional visualization of these things. This is beautiful, and it was actually quite hidden from the global sensitivity indices as well, because there is a lot of overlap going on. and they cannot capture this intricate influence of B. But on SimDec visualization, you can see it, and this U shape actually persists in different states of A. So that was quite a cool mystery to discover in the superconducting magnet design model. Yes. Then what else? Another bunch of patterns here. Oh, this is from carbon footprint. You can see emissions on the x-axis and the different types of masks for COVID that we were analyzing, reusable or single use. And on the first graph, we can see some peaks, which are not explained for single-use single-use masks. But then when we take only that part of the data set and repeat the analysis with SimDec, then we actually are able to pinpoint which peak is coming from which combination of input variables. So you can see every peak has a distinct color, so we can really say what's going on. So that's one way. We actually did it in a quite many applications where we needed to zoom in into the model in order to explain the complexity that's going on in different parts of it. Yep. So, yeah, beautiful things that we realized with SimDec were numerous heterogeneous effects, very different, very different. It's surprising. It's like even impossible to categorize. Seriously, it's models can be really cool to see how they look. And in that sense, my personal feeling about SimDec is like a window into the model behavior. So hop, and you can see immediately what's going on there. And similar feedback we got from the model learners as well. Then another interesting thing is that we went way beyond standard input-output analysis, because there were quite a few instances where we were checking a kind of intermediary variables in there that kind of either outputs that represented different blocks of the model and how they affect the output, or inputs that are, well, not exactly inputs, but kind of functions that comprise a bunch of inputs together. So the variability is modeled in the inputs, or uncertainty is modeled in the original inputs, but then we look into bundles of them, and that's where analysis gets more interesting and less straightforward, but sometimes more useful for decision support or policy making, or whichever context we're dealing with. So yes, this is one yet quite underexplored direction that we want to pursue in the future, is that how further we can advance the sensitivity analysis in that sense, because it's really breaking the convention of analyzing how output is dependent from its inputs. And answering Julian's question from before, that's why we also like our simple binning approach, because it's able to compute indices on whatever. It doesn't have to be input or output or independent or anything. It doesn't need to have many observations. In the 12th chapter on CERN, there was one portion of the model, by the way, where we analyzed only 170 or so data points, and still made some sense out of what's going on in that portion of the data. And finally, with SimDec, we are moving away from this deterministic paradigm of computing optimum values, thresholds, some other things where we can make binary decisions, or maybe not binary, but very closed kind of decisions. And there a lot of things suddenly come into the view. First of all, errors and model refinement. At the moment, you do not treat model as for computing a single output value. You shake it, you get a lot of insight into its behavior and also its errors. Then new insights were obtained from realizing that there are varying degrees of uncertainties in different scenarios or options or something else, which is also something that you can see with SimDec easily. And then, like, remember in our reliability chapter, there were distributions that were sub-distributions that were narrow and some that were very wide. And then finally, there is a really cool output of that moving away from determinism is that you're finally, instead of just answering a closed question, you can actively develop a strategy. So you can say, okay, if my X1 is low, then I want to go that way. If my X1 is high, then I want to use a different set of variables to tune my system, etc., etc. So yes, that's what we have seen in different applications. You see the tags here. So if some particular aspect of this insights is interesting for you, you can go to the respective chapter and read more about it. That's it.
Thank you, Maria. Let me just make one comment at the end, and then I'll leave you exposed to any questions about either this session or the application sessions that come along. Just sort of a comment in that SimDec itself is application agnostic. You can apply it to any setting, and the book showed that, you know, from the very small type of personal decision making up to this massive data analysis involved in the CERN case, and everything in between. So you can use it on anything. The technique is available through, you know, the different computer packages or the dashboard. I mean, all you really need is an Excel CSV file to upload to it, and you can play there. Obviously, if you want to do more of the nitty-gritty stuff and really delve into it and massage it, you'll have to pull out the computer code, which is readily accessible. So that is there. There is no penalty to trying it. You know, if you've got something, try it. This isn't an observational tool. We want you to use it, and it's readily accessible to use. One of the outputs of this obviously are the histograms and the visualizations. It's easy to create a histogram, but as Maria showed, the interpretations of those do require you to really get off your horse and examine the histogram itself. So don't be fooled by, you know, oh, it's a histogram, it's easy. And I recall one of our reviewer comments right from, you know, the early times where they were dismissing all of this as it's just a histogram. Well, no, you actually have to go in and interpret what is there. But if you understand the kind of the natures of how these histograms will display certain effects, you can pull out magical interpretations of what's going on in your data and in your model. And particularly for our aspiring graduate students who are wanting to publish, this will provide you with information that you will not be able to get from any other technique. So it is well worth putting in just you know, even a couple of weeks of playing around with your data to see what you can pull out of it in terms of interpretation. And it's something that you won't get from other packages, other methods, and it's available to you for free. I mean, you don't have to do anything other than run the data and see what it does. I mean, this is a participation sport. It's not an observational one. And I think if you come back to some of our subsequent application sessions, you will see how people have done this on various different settings, some of which may be of more interest to you than others. But it's well worth putting the effort in to just play with it, see what happens. And if there's nothing that happens, you don't have to. There's no obligation. It's something that you can gain a lot of insight and information from doing that. So.
Or if some errors happen, then you're very welcome to reach out to us and we will help. It's all in the development and things might happen.
And she.
Thank you, Julian. I totally agree with you. It's a wonderful tool. Suppose I'm trying to convince my graduates to use it. Some already downloaded it. Suppose they try to write a paper after doing simulation. So how do they convince the reader, say, what is the mathematical foundation of this SimDec? So how do they write it? So any mathematical foundation why this kind of a decomposition will work, and it will work well under this some rigorous mathematics. Is there any reference we can read or you can point out we can use in a way to convince the reader that's the right tool we should use?
Do you want to feel this one, Maria?
I don't know. Is our book a good reference for that?
Yeah, of course. It's a good book, but any specific chapter we should say that's the reason we should use this tool. That's the yeah.
Yeah, I guess chapter number 1 would be a good one if you want to say that we're choosing SimDec out of all the landscape of sensitivity analysis methods. That's why chapter 1. Yes.
Thank you. The other thing is maybe it's a suggestion. I would think if you could write a guidance or how to understand the output, because one of my students tried it. He got the histogram is like a very high, sharp spike with a little bit of perturbation. Then he got no idea how to write what it does mean in terms of the output.
That's chapter 2.
Okay, but still he read it, but still cannot actually explain it well. So that's I was thinking. Do you have a more detailed tutorial or something we can read or in the future?
Yes, that's actually chapter 2 indeed. It's very practical. It's like a tutorial. And for cases like that, it would advise you to go to the box plots visualization. So when you have just one peak or something unreadable as a histogram, try box plots. You'll see more.
Okay.
Yes.
Thank you. Thank you.
Yes, but again, since it's all relatively fresh and developing, and we don't have yet documented all the possible cases and answered all the possible questions, that is exactly why we have our Discord community, where we answer questions like that. So welcome there and don't be shy. And instruct your students not to be shy to ask questions there.
Yeah, that's true. Just, I mean, fire any issues that you have of interpretation and so on to the Discord group, and you will get responses from that. I put in, there are a number of papers that we do have that are floating around. I put in a reference to one of them, which you can kind of use as a source and sort of citing for this thing. The heterogeneous effects part. So there are pieces that are, in addition to the book, there are various papers that we have, and then there are various ones which are at different stages chugging through the process that one can cite as well. But if you're encountering any sort of issues, we're more than happy to take on certain things as well as if there's some interesting research, interesting ideas that are popping out or falling out, or interpretations that need to be made, we're happy to be involved in those.
Yes, and the reference that Julian just posted in the chat, uncovering heterogeneous effects, it's indeed our like a key work on high quality work on SimDec that summarizes its main benefits over existing methods. It's done with Stanford collaborators in a relatively prestigious journal. So this is something that you can safely reference, and also that's the work where you can find all the other relevant references to other work, reviews, methodologies, justifications, everything in that respect. Yes, and if there is one article out of all SimDec work to read, it's that one.
And all of the papers that we do have are open access as well. So you can either go to our web pages and pull that out, or the SimDec site as well. Has most of the papers, I think.
Yes, and warning, ChatGPT is still not that very good with SimDec. It mixes up a lot of concepts in there, I guess, because it's relatively new. So be careful with ChatGPT. Yeah.
Are there any other questions that we can address now?
Okay, should we post a link into the chat for the Discord if somebody is not there?
I already put that in.
Oh, perfect, thank you. Yes, so the link is there. Join, don't be shy, ask questions. It exists for that. And from time to time, we also will be announcing there the new presentations with those particular case chapters and their model owners presenting those findings and research. And then we are also discussing some relevant literature from time to time, asking some silly questions back to you, and trying to keep very moderate but still activity in the server. Welcome.
And actually, further to respond to your question, Sinchi, if Geetha is actually looking for specific answers to shapes and stuff like that, which is not readily apparent, she can fire off questions. If it's very difficult, fire it to Maria, but she can fire off questions to us as well. So we're happy to deal with those.
Mm-hmm. Absolutely. And it's already not uncommon when researchers just come there and report some of their results asking help in interpretation. So that's what we are created, that community. But yes, thank you so much everybody for participating. It was cool to have such an audience here with this presentation. I hope you enjoyed and found it useful. Yes, stay in touch for more presentations, and welcome using SimDec.
Thank you, everybody.
Thank
Maria.
you.